In this video today, I'm going to go over the perimeter, and we're going to do that today of various different shapes, but we're going to do that by adding and subtracting polynomials. So our AKS IOA is 1a and 1b, so we're going to do interpreting polynomial expressions of varying degree that represent a quantity in terms of its given achievement. So basically, doing it in context as it relates to perimeter today, and then we'll do area next, okay, and volume. So perform operations with single variable polynomials, add, subtract, multiply. Okay, that's what we're doing. So today's objective is I can find perimeter of shapes with polynomial side lengths. So I'll move this down here so it's out of the way. Polynomials, any expression that's combined is a combination of one or more monomials connected via addition or subtraction. So 2x squared, that's a monomial. 6x, negative x to the third, 3x to the fourth, and 2. Those are all monomials. The next thing it says here is when you write polynomials, they should be written in standard form, the standard form of polynomials, where the terms are written in descending order by degree. So basically, we're going to take the largest degree right there, and then we're going to write them in descending order from there. So we're going to write 3x to the fourth, and then minus x to the third, plus 2x squared, plus 6x, plus 2. Now, you might not think this is important, but as we work through the problems, it's going to help us organize things in such a way that it's going to help the setup of the problem be a little bit easier and us getting our answer a little more effective. So it says down here, notice that the exponents are getting smaller. Recall, you only combine like terms. So remember that x to the fourth is not a like term with 6x, right? 2x to the second is not a like term with negative x to the third. So example 1 says adding and subtracting polynomials. So what is the difference? Remember, the difference means we're going to do subtraction, right? So I'm going to write subtraction up here because that's what that means. Okay, so what we're going to do is we're going to take this first term right here and we're going to write it in descending order. So my 5x to the third minus 3x squared plus 2x plus 1. Okay, so again, 3, 2, 1, nothing. Okay. Then what we're going to do is we are going to write our second term again in descending order. So we have negative x to the third plus 5x squared, and then we have minus 7. Now, this is where it gets a little tricky. So I need you guys to notice that it's subtraction, right? So we're going to subtract the second term from the first term. What I do with that is I change all the signs of the second term. Okay, of whatever that second, of the second function, okay? So I'm going to change this to a plus, I'm going to change this to a minus, so that's now gone, and I'm going to change this to a plus, okay? Now that I do that, then I'm going to combine the terms, because remember, we're going to change the signs because we're subtracting. And if we subtract the negative, it is addition, right? Okay, so that's why we're doing this. So, and also remember that there's a 1 in front of there, so 5 plus 1 is 6, so this is 6x to the third. If we have two negatives, we just combine them, add them together, and keep the sign, right? So this is going to be minus 8x squared because 3 plus 5 is 8. We're just going to bring down that 2x because there's nothing else that combines with it. And then we're adding our 1 to our 7, so that's 8. So that is our answer right there when we subtract those two polynomials. So now this next one says sum, and that means what? This means addition, right? Notice they are the same two functions. So we're going to see what happens differently. Okay, so we are going to write 5x to the third minus 3x squared plus 2x plus 1. This time we are going to add negative x to the third. There's that term, and then we got our plus 5x squared. There's that term, and then we got our minus 7. Now when we're adding, we're not changing the signs of anything. Okay, really important that you see this difference. Okay, so what is 5 minus, again, remember there's a 1 in front of there, so 5 minus 1 is 4, right? So this is going to be 4. Let's change this to a different color. 4x to the third. 5 minus 3 is 2, so this is going to be 2x squared. Again, we're just bringing down our 2x plus our 2x, and then what is negative 7 plus 1? That's going to be minus 6. So there's our answer for this one. Remember, when you're adding, you're not going to change the signs, okay? So go ahead and do these two and come back to me when you're done. So here again, we're going to write this in descending order. 3x to the third minus 8x squared plus 4x minus 5. Notice again, we're subtracting, so I'm going to put my minus sign out there. And I'm going to go ahead and write the terms again in descending order. So I got my 2x to the third minus 7x squared plus 6x plus 5. And remember, we're going to change all these signs, right? So we're going to make this negative, we're going to make this one plus, we're going to make that one negative, and we're going to make that one negative, okay? So then we're going to change that to a plus sign once we've changed all those signs. So now what is 3x to the third minus 2x to the third? That's going to be just x to the third, right? Because that would be a 1 out in front of there. Remember also, when you are combining like terms, you always subtract. Just keep the sign of the bigger one. So this is going to be 8 minus 7, but that's going to be a negative x squared because the 8 was the bigger number. Now we are doing 4 minus 6, so basically 6 minus 4 is 2. So this is again going to be a negative 2x. And we've got 2 negatives here, so this is going to be minus 10. So that's our answer there, okay? Go ahead and pause the video again if necessary and go on and do the next problem. Here again, we're going to write it in descending order. 3x to the third plus x squared plus 4x minus 5. Going to once again put plus out here this time, and we've got our negative 2x to the third plus our 2x squared plus our 6x plus our 5, okay? So what is 3 minus 2 again? That's just 1, right? And then what is, remember there's a 1 out in front of here, so 1 plus 2 is 3, so this is 3x squared. 4 plus 6 is 10. And negative 5 plus 5 is 0, so we're not even going to put that term down there because we don't need it. Okay? All right, so this next one says find the perimeter by adding and subtracting polynomials. A model of a house is shown below. What is the perimeter in feet of the model? Label the side that has 1 tick and the side that has 2 ticks. Okay, so notice this has 1 tick here, right? So does this. So this over here is going to be 6x minus 4. And notice we've got 2 ticks here, which means it's congruent or equal to that one. So this is going to be 12x plus 3. So what that means is because we've got 2 at the top, and remember what perimeter means is finding the distance around the outside of an object, right? So we got 2 6x minus 4s, don't we? So we're going to go 2 times our 6x minus 4, and that equals, remember, we are going to distribute that 2 to both. So 2 times 6x is 12x. 2 times negative 4 is negative 8, right? Going to do the same thing with our sides. That was the roof, right? Now we're going to talk about our sides. So we're going to again go 2 times 12x plus 3. We are once again going to distribute it. So we're going to go 2 times the 12x. That's going to give us 24x. 2 times the 3. That's going to give us 6. And then we're just going to bring in this 14x plus 13. 14x plus 13. Okay. So you guys did this kind of math in elementary school. So what we're going to do is we're going to add 4 plus 4 plus 2. That's 4 plus 4 is 8 plus 2 is 10, right? So that's going to carry that 1. 1 plus 1 is 2 plus 2 is 4 plus 1 is 5. So that's going to be 50x, right? Here, hopefully you can see that when we combine the 6 and the 13, we get 19, and 19 minus 8 is 11. And you can do all this on your calculator if you're not sure. All right, so the next one says find the perimeter of the triangle below. So I'll show you a couple of things about this. So I'm going to go ahead and do the biggest side first, 4r squared minus 6r plus 1, because it has all the terms in it, the r squared, the r, and the constant, right? So go ahead and do the other two sides, line them up, and then add them together. Come back to me when you're done. Okay, so I'm going to do this one next, 5r squared plus 3. Then I'm going to do this one, 7r minus 8. I am going to add all 3 of these sides together because that's what perimeter means. So that's going to give me 9r squared because 5 plus 4 is 9. Then we got negative 6 plus 7, right? So that's going to be plus r. And then we've got 4 minus 8, so this is going to be minus 4. There you go. All right, the next one says find the perimeter of the square below. 2 keywords, perimeter and square. What do you know about all the sides in a square? They're all the same, right? So what are you going to do with the 2x squared minus or plus 3? Yep, you got it. Multiply by 4. So you're going to do 4 times 2x squared plus 3. Once again, we're going to distribute that 4 to both those terms. So 4 times 2x squared, sorry, is going to be 8x squared. 4 times 3 is 12, and that's our answer right there. Okay, so this next one says, Taylor has a garden shaped like a trapezoid. Each side length is represented by a polynomial expression. If the perimeter of the garden is represented by the expression, and it gives us the expression, what's the length of the missing side? So hopefully you see that we don't have this side over here, right? See that side right there where it has question mark? So to find the perimeter, we have to add all 4 sides together. Well, we don't have all 4 sides. So what are we going to have to do here? We're going to have to add the 3 we have and then subtract them from our perimeter up there. Y'all see that? So that's what we're going to do. So I'm going to start with this one down here, and I'm going to show y'all how I would approach this problem. So it's 4x to the 4th plus, and I'm going to do 0x to the 3rd because I don't have one of those. And that gives me a space holder in case I get an x to the 3rd. Then we've got minus 2x squared minus 6x, and then I'm going to just again say plus 0. Again, trying to just get a space holder for all those terms so that if I find something that matches up with it, I put it underneath it. Then I'm going to do this side, this one up here. Okay, I'm doing 3x to the 4th, and I got my minus 3 all the way over there, right? Then I got my 3rd side right there. That is 4x to the 3rd, right? So 4x to the 3rd goes under that 0x to the 3rd plus our 6x plus our 6, okay? So now all we're doing with these again is adding the 3 of them together to see what we get, right? So we get 7x to the 4th plus 4x, bringing this one down, negative 2x squared. Negative 6x plus 6x gives me nothing, right? These two are going to cancel each other out. And then 6 minus 3 is 3, okay? So what are we going to do with this equation? We're going to subtract it from our original, okay? So I'm going to rewrite. I'm going to do this. I'll do it over here. So I'm going to write the one that we had originally, what it says up here. The perimeter, 7x to the 4th plus 9x to the 3rd minus 6x squared plus 8. And then I'm going to subtract from it this one right here, which is our 7x to the 4th plus 4x minus 2x squared plus 3. Now remember, we are subtracting it, right? So that means we're going to change the signs. That's going to end up being a minus. That's going to end up being a plus. That's going to end up being a minus, okay? And then we're going to make that a plus, okay? So these two cancel each other out, right? What is 9 minus 4? That's, oh, by the way, I forgot to put that 3rd power right there, didn't I? So that's going to be 5x to the 3rd. Negative 6 plus 2 is going to be negative 4x squared. And then 8 minus 3 is 5. So this is our side that we were missing. And we could check that by adding these two together, right? And it should then equal that one up there. All right, go ahead and do this problem and then come back to me when you're done. Well, notice it's already written in descending order, right? That was nice. And we are going to subtract our x squared minus 5x plus 1. Keeping in mind again, what are we doing with all those signs? Changing that to a minus, that to a plus, that to a minus, right? Then changing that to a plus. Bring this one right down, 3x to the 3rd. 4 minus 1 is 3, so this is going to be plus 3x squared. 5 minus 3 is going to be plus 2x, and 5 minus 1 is going to be 4. Any questions? Okay. All right. So this last one says Danielle completed the operation. Subtract these two, okay? But she made an error. So this is an error analysis problem. I want you to find out what her error is and correct and complete the operation. So notice here again, this is Danielle's work, okay? She's doing what's called the horizontal method. So this is what she did, right? See, this is right there. And then she's got minus all of that, right? So she started doing like terms next to each other. I don't really like the horizontal method. I use the vertical method because I think it helps eliminate errors. I talked about that at the beginning of the lesson. So go ahead, pause the video, do this problem, and come back to me when you're done, and let's see if we can talk about what the error was. Okay, so first of all, I'm going to write 8x squared plus 2x minus 6, right? Then we're going to subtract, and I'm going to write the other term, 5x squared minus 3x plus 2. Remember, we're subtracting it all, right? So I'm going to make that a minus, going to make that a plus, going to make that a minus, and then going to add it. So what is 8 minus 5? That's a 3x squared. Well, that was the same term, wasn't it? But then 2 plus 3 is 5, right? So that's 5x. So that definitely wasn't right. And then negative 6 minus 2 is negative 8. So what was the error that she made? Notice here, didn't change the sign of that and didn't change the sign of that. That's one of the things, again, this is the most common error that occurs when people are subtracting polynomials. You have to really, really watch that.